let's move forward. The next speaker is also an associate professor of the Department of Manufacturing, Engineering, and Management of De La Salle University, Dr. Robert Kerwin Bilionis. He had got a fellow in Leaders Innovation Fellow from the Royal Academy of Engineering, United Kingdom. His area of expertise is artificial intelligence, cloud and data engineering, computer vision, technology and management. Ladies and gentlemen, Dr. Robert Kerwin Bilionis. Robert, nawala yung presentation mo.
Yes, madam. Okay, good morning to all of you. So on behalf of my co-researchers, Dr. Edwin Sibinco, Dr. Lawrence Ganlim, Engineer John Antonio Jose, Dr. Alexis Amfilione, and Dr. Elmer De Dios, I'll be presenting our research about big data video analytics and applications towards smart city traffic management. Okay, so this is actually done under the Intelligent Systems Laboratory of the Center for Engineering and Sustainable Development Research of De La Salle University, Manila, Philippines. Okay, as a brief background of the study, so the goal of this study is to actually come up with a vision-based system for microscopic traffic scene analysis and understanding. And using these vision systems, we want to calibrate a traffic flow model using actual information from roadside cameras. We also aim to demonstrate an understanding of different levels of traffic scene analysis from a simple detection, tracking, and classification up to higher levels of understanding such as vehicular and pedestrian dynamics, traffic congestion build-up, and multi-agent interactions. So now we actually want to demonstrate the capability of the system towards creating smart cities, especially in the mobility category. Okay, so when we talk about smart city, so this is an urban setting that apply technology to benefit the citizens. Okay, so according to the IMD Global Smart City Index, Manila was only ranked 94th out of 102 cities. So this is a global study, and the table shows the top 10 smart city as of 2018. Okay, now in this slide, so we can now see how they come up with this, how do they rank this smart city. So they use a smart city index where they gather information about the different cities. They conduct surveys. So in particular, they're looking for for these 15 indicators. Okay, so for the mobility category, they are looking at the road congestion, air pollution, security, public transport, green spaces, social mobility, and citizen engagement. Okay, and now they are also looking at what type of technologies in the mobility category are helping this or helping the cities to become smart. Okay, so for example, what is their regulatory frameworks with regards to car sharing apps or ride hailing apps? Do they have bicycle apps? Do they have parking apps, or as well as online scheduling and ticket sales for public transport? Now we want to integrate the concept of the smart city to the intelligent transport systems, wherein when we talk about intelligent transport systems, okay, so we want, this is further subdivided into different component areas such as ATMS or Advanced Traffic Management System, ATIS, Advanced Traveler Information System, CVD, this is a Commercial Vehicle and Devices, APTS is Advanced Public Transport Systems, ABCS is Advanced Vehicle Control System. ARTS is Advanced Rural Transport System. And the holistic part of this is what they call the smart mobility, wherein they can actually integrate technologies such as cloud and big data. So the overall goal is to have a connected, shared, driverless, electrified, tailored, and automated mobility ecosystem. Okay. So now here are the key enabling technologies for a smart city. Okay, so in this specific study, so we have used these technologies to come up with solutions with regards to the traffic management. So we've used AI and machine learning, big data technologies, cloud computing and GPU-based computing, and video processing and analytics. Okay, so when we talk about AI, machine learning, and video processing, so it is not only wherein we gather video sources and store it into some storage. We want to understand what's happening on this video. So we want to analyze, we want to process these videos. Okay, so on the process of making a system that is AI-based or machine learning-based, so some activities like data labeling, model testing, or training are being conducted. Okay. So we also have the concept of big data analytics as perspective on big data. So when we talk about big data, for example, when we talk about the YouTube, the amount of videos being uploaded per minute. So there are around 300 hours or 300 hours of videos being uploaded in YouTube in during a 1 minute time. Okay, so when we're talking about those kind of huge amount of information and fast velocity, so we are talking about big data analytics. So originally we have 3 V's of big data. So we are only looking at the volume, the veracity, and the velocity of the data. But as of today, we have now this 8 V's of big data, which includes the volume or amount of information. What is the value of this information? The veracity, or can we trust the source of this information or data? How do we visualize the data? The variety of the data, are we only processing video sources, or are we actually also using picture-based or image-based data, or text-based data? We are also looking at the velocity, wherein the amount of the information being processed per unit time, the viscosity, or does it stick, or does the data stick, or the amount of time wherein the data is created before it is actually erased or destroyed or transferred to another system, and the virality of the data. So this is the big data, or the 8 B's of big data. Okay, so now how can we use big data analytics and traffic management? So here are some technologies that our research team has already developed and continue developing. So we can actually use it on traffic congestion analysis. We can, so for example, if we have actual information about road scenarios, that now we can calibrate traffic models and simulation. We can also understand what's happening on the people, mobility characteristics, even traffic violations apprehension. Okay. And there are other applications that can be applied, or the use of video processing, big data analytics in a smart city concept. Okay, so recently we are also trying to shift into a cloud computing platform. Originally, we've done a local or GPU-based computing, but we've done some research about the feasibility, viability of using cloud computing in crunching our analysis for video processing. So here is a brief background on our methodology. Okay, so now here is the road traffic scene analysis framework. Okay. So we have the problem domain. So first, for example, we want to understand or we want to have a solution for traffic congestion, which can be categorized, for example, as volume-based or behavior-based traffic congestion. When we talk about volume-based, it is just the sheer amount of vehicles in a road that overwhelms the road capacity. Or it can be a behavior-based type of traffic congestion, which includes the commitment or the traffic violations. Are there accidents, or what are the driving behaviors of the people using the road? Okay, for the solution domain, we want to have a holistic understanding of what's happening in the road. We are looking at both on these aspects like the vehicle, what's happening with the vehicles, okay? What are also happening with pedestrian and the infrastructure deployed in that area or piece of road, okay? And the interaction between these agents. Okay, as an example or pilot the deployment, we have an actual CCTV camera network deployed in Manila, Philippines. Okay, so here are some example of the CCTV footages. We are using both real-time videos as well as offline videos for our research studies. Okay, so the vision-based machine learning. So as I mentioned previously, we want to have an understanding of, let's say, low-level understanding of what's happening in the road. For example, can we detect vehicles? Can we detect people? Can we classify these vehicles? Okay, and so how do we do it? We actually train the system to have so we can use the videos for different applications. Okay, wherein we can train the system, for example, for vehicle detection, for people detection, and so on. Okay, so here are some of our results. Okay. Afterwards, so we have used, for example, traffic simulation software such as VSIM, wherein we plotted the actual information that we got from road scenarios, and we plot it into our traffic model. Okay, so basically we calibrate the traffic model for VSIM using actual information from the road. Okay, so based from the simulated results, so we can actually observe the traffic congestion build up in this T-type intersection type of road. Okay. So now this is another, we use another data set for this using a big data set. Okay, so we use we are trying to identify basically the traffic volume in a specific road. This is a big road intersection, wherein we also want to identify the composition of those vehicles or volume distribution. So for example, we want to identify how many private cars are present during these specific time frames. Okay, so we have observed based on our simulations that for this windows of time, there are around 55 to 70% traffic volume from private cars alone, and only 15% from public utility vehicles such as PUVs, jeepneys, and buses. So this continuous surge in volume of private cars cause a developing traffic congestion. Okay. So as a summary or a conclusion for this study, so we actually demonstrated applications such as vehicle detection, tracking, classification, and how to use it for higher level of understanding to make to help on the decision-making process of the people involved in traffic management, such as we have estimated volume estimation and distribution, the vehicular flow patterns, and traffic congestion. We have calibrated microscopic traffic flow model using a T-type intersection. Okay, and the simulated result shows that traffic congestion buildup is consistent with actual road scenarios. Okay, so for future recommendation, so we actually want to integrate, for example, speed estimation, driving waivers, and car following models into the model to have a better understanding or approximation of the traffic modeling and simulation. And we can also do it in a macroscopic or mesoscopic type of traffic modeling, or for example, citywide traffic flow modeling for the smart city concept. Okay, that's all. Thank you. So here's some of our references. Okay.
Okay, thank you very much, Robert, for that very insightful information and presentations towards making Philippines, Manila and other cities in the Philippines becomes a smart city.